In 4.5, we are looking at how functions interact with each other on a few different levels. First, we're going to look at graphically. This will be sometimes as how do they intersect and also inequalities. So we are looking at the parabola x minus 2 squared minus 4. And we are asking the question, when is this function, this parabola, greater than 0? So we know what a parabola looks like, but we need to talk about what this means greater than 0. Now, you're used to seeing functions written as f of x equals a parabola, but f of x, a function of x, can also be a constant. And so what we're saying is, when is this parabola greater than the function f of x equals 0? Now, what does f of x equals 0 mean? Hopefully you recall that when you have y equals a number, it is a horizontal line. So this is a horizontal line when the y value is 0. That is actually just the x-axis. So we are asking the question, when is this parabola greater than or physically above the x-axis? And so this is visual. Where do you see parts of this parabola that are above the x-axis? So hopefully you can see that that chunk right there is above, and this chunk right here is above, and also that all this stuff in the middle is below the x-axis, or in this case is less than 0. This says x minus 2 squared minus 4 is greater than 0. So we're looking for all the x values where this parabola is physically above the x-axis, physically above the line y equals 0. And so we identified these two green chunks that are above and all that orange stuff that's not. And when we ask this question, where is it above, we're asking for x values. And so if we look at these x values, these are the points where it changes. So over here, this part is above, and as soon as you cross that x-axis, this part is below. And similarly, this part is still below, but when it hits the x-axis, this now becomes above. So those zeros of this function, the zeros, the x-intercepts, are the point where it changes from being above 0 to less than 0. We typically write up this solution in terms of interval notation. So the smallest value where this is above the y-axis is actually negative infinity, because this goes on forever up into the left. And so it's negative infinity, and it goes all the way until it hits that x-intercept, which was at 0. Now, if you'll notice here, this says greater than. 0 is not greater than 0. For that reason, we have to use parentheses on this side because it's not actually part of the solution. This is open. We use this symbol, this big U stands for union. And then we say, okay, what's the next time that it starts being above the x-axis? And once again, it starts at 4, and because this is open, it's parentheses right here. And when does it stop being above the x-axis? Well, it goes forever above the x-axis. So this represents the x values where this parabola is greater than the line y equals 0 is greater than the x-axis. Now, we could have changed this problem up a little bit. We could have said, instead of this parabola is greater than 0, we could have said something like this: x minus 2 squared minus 4 is greater than negative 3. So just like this 0 is the same as the line y equals 0, this is actually the same as the line y equals negative 3. And if I sketch the line y equals negative 3, that goes here, and that goes here. Now, we are no longer talking about x-intercepts, but we are talking about where this parabola intersects the line y equals negative 3. This is very visual. You can see that it crosses it right there and right there. So similar to how we looked at where is it above the x-axis, we're now going to look and see where is it above the line y equals negative 3. Well, right here, that chunk is above, and right here, that chunk is above. And then this stuff down here is below. So similar to how we wrote up the first piece, in this question, when is this parabola greater than -3, we would write it in a similar fashion. When does it stop being above? Well, once again, it goes all the way to -infinity. But where does it stop being above the line y equals -3? And the answer is right here, right there. And that has an x value of 1. So we're going to say all the way to 1, union with, and it starts being above the line y equals 3, once again, right here at this x value. And that, as we see, is 1, 2, 3. That's an x value of 3. So it starts at 3, and once again, it goes on forever. So we are looking for the points of intersection because those define for us where this changes from being above to being below. Next, we could change this up a little bit further, still looking at this parabola. So still looking at x minus 2 squared minus 4. We could now say, when is it less than 0? Well, let's make it interesting, less than or equal to 0. So if we go back to what we had originally, which was looking at the x-axis, we still have those same zeros right there and right there. But when we say less than or equal to 0, we're actually now looking for the part that's beneath the x-axis. And so the points of intersections don't change. Now we're just identifying a different piece. Now we're identifying the stuff that's underneath. So this is the same picture, the same lines, but we're asking about something different. So when is it below? Well, it starts being below once again at 0, and it stops being below again at 4. Now, one key difference is that I included the points of intersection. It says less than or equal to. So here we're going to have brackets. So from an x value of 0 all the way to an x value of 4, this parabola is underneath, less than the x-axis, less than or equal to 0. So we would write that as 0, comma 4 with brackets on both ends to denote that those endpoints do count because we said less than or equal to 0, and those are the zeros. So graphically, we look for how these two different functions, the parabola and the horizontal line, how they interact with each other. Now, where this gets more interesting is it doesn't have to simply be a horizontal line. You can actually make much more sophisticated versions of this. And we're not going to solve out these sophisticated versions, but I just want you to see what they look like. So if I have a parabola right here, and I sketch it out, and instead of just a boring horizontal line, I could actually have something like this. Now, this is a linear equation, and it's not particularly fancy. We could actually figure out exactly what the equation of that line is, but we could still ask a similar question, which I guess maybe we should. Let's see here. If I'm going to use point slope form, so the parabola, I put the vertex at -2, so that's going to be x plus 2 squared, and it's one step up, so that's x plus 2 squared plus 1, that's that function right there. And I drew this line in here, and we'll put this in initially, we'll put it in point slope form, because that'd be a bit easier. Equal sign there. So point slope form, to refresh your memory, is y minus y1 equals m times x minus x1. So I see that my slope, I go down one step to the right 2, so my slope is -1/2. And if I pick a point, let's see here, if I pick a point, I'll say this point right here, so that's -1, +4, so I have -1, +4. And if I use those, I get y minus 4 equals -1/2 times x minus -1. So y minus 4 equals -1/2 x. We'll combine those to say x plus 1. Now to put this into function notation, I'm going to add 4 to both sides. And I have y equals, or f of x equals, because I'm I'm intentionally putting it in function notation. Negative 1/2 x plus 1 plus 4. Now, I certainly could distribute and clean that up, but in this moment, it doesn't really matter. But the picture I'm looking at, I could ask a question like this. I could say, x plus 2 squared plus 1. That's the parabola. When is that parabola less than or equal to this line? This line right here. And I'm going to pull this over real quick. Right there. When is this parabola less than or equal to this line? Less than or equal to means physically below. When is the parabola below the line? Well, it starts being below right here, and it stops being below right here. We would look at the x values from here all the way over to whatever that x value is right there. It looks very fractional. But that's what we're talking about. We can do it for horizontal lines. We could actually do this with two different parabolas and kind of how they interact with each other. So whether it's a horizontal line or a slanted line, this right here means the same thing as it up above, even if it's not a nice, neat horizontal line. Where are the points of intersection? When is one above the other? When is one below the other, depending on what the question asks?